The space race is accelerating now more than ever because China's Chang'e 6 mission has retrieved the first ever samples from the lunar far side. And what those samples have revealed has stopped scientists cold. We are talking about volcanoes that should have died billions of years ago, proof of how the moon was born, and fragments of ancient asteroids that may hold the answer to where Earth's water came from. So why now? Why are we interested in the moon? Because the moon is sitting on an energy source so valuable that whoever controls it controls the future of power on Earth. China knows this. The United States knows this. And right now, China is the only nation on Earth holding samples from the one side of the moon nobody else has ever touched. Let's get into what this space mission found. The first thing the Chang'e 6 samples discovered was volcanic activity, and it should not have been there. Earlier studies suggested that volcanic activity on the far side shut down much earlier than on the near side. The reasoning made sense on paper, because the near side is loaded with radioactive elements, specifically potassium, rare earth elements, and phosphorus, a combination scientists call creep. Think of creep as the moon's internal heater. Those elements generate heat which drives volcanism. The far side had none of that, so it should have gone cold and quiet billions of years ago. But that is not what the samples showed. Researchers from the Guangzhou Institute of Geochemistry at the Chinese Academy of Sciences studied rock fragments from the Chang'e 6 collection and used a dating technique to determine precisely when that rock hardened from molten lava. They published their results in the journal Science. The answer stopped them cold 2.83 billion years ago. Volcanoes on the far side of the moon were still erupting nearly 3 billion years after the solar system formed. A separate team identified two distinct volcanic episodes in the same samples, one around 4.2 billion years ago and another at 2.8 billion years ago. That means volcanic activity on the far side lasted for at least 1.4 billion years. The science said this was impossible. So what kept those volcanoes alive? The best answer researchers have found points to the formation of the South Pole-Aitken Basin. This is the largest confirmed impact crater in the entire solar system, stretching 2,500 kilometers across and plunging nearly 8 kilometers deep. A scar so big, it is visible from orbit as a dark ancient bruise on the lunar far side. That impact struck the moon around 4.25 billion years ago, though some teams date it as far back as 4.33 billion, with energy estimated at 1 trillion times the force of an atomic bomb. It thinned the crust in that region so dramatically that the hot material beneath had a much easier path to the surface. This catastrophic collision that formed the basin may have accidentally kept the volcanic door open for over 1 billion years after it should have been permanently shut. But here is the thing. The volcanoes were just the beginning, because hiding inside that same cold, dry mantle was evidence for something far bigger, a confirmation of the moon's origin story that scientists had been chasing since the Apollo era. Scientists decoded how the moon was born a long time ago, but there was a gap nobody could close. The theory went like this. About 4.5 billion years ago, a planet roughly the size of Mars collided with the early Earth. Scientists call that planet Theia. The impact was a full collision that partially vaporized both worlds, threw an enormous cloud of debris into orbit around Earth, and that debris slowly came together to form the Moon. This is called the giant impact hypothesis, and it has been the leading theory of lunar formation for decades. If the Moon was born from material ripped out of the early Earth, then the deep interior of the Moon should be bone dry. The extreme heat of that collision should have boiled off almost all the water from the material that became the Moon. And so, the far side mantle, being the oldest and least contaminated part of the Moon, should show this most clearly. For decades, scientists could not confirm this, because every sample came from the near side. Then the Chang'e 6 results came in, and the far side mantle samples are extraordinarily dry, drier than anything returned by any previous mission. A study published in April 2025 by China's Institute of Geology and Geophysics gave the first direct measurement of water content in the far side lunar mantle, recording the lowest level ever measured, and it was hailed as a milestone in lunar science. This dryness matched the giant impact prediction almost exactly. A separate study confirmed evidence of a global magma ocean that once covered the entire Moon in its earliest days. As that ocean cooled, lighter material floated up to form the crust, and heavier material sank to form the mantle. That cooling process created the layered, lopsided structure the Moon has today. Again, exactly what the giant impact model predicted. For the first time, scientists had physical evidence from the one place that could settle the argument, and it settled it. The Moon was once part of this planet, torn away by a collision so violent it half vaporized the Earth. And a robotic arm on a Chinese spacecraft confirmed it by picking up a handful of soil from a basin no human has ever seen with their own eyes. But the samples were not done talking, because mixed into that ancient lunar soil was something that did not come from the Moon at all. What Chang'e 6 brought back was not simply Moon rock. It was a 4.25 billion year archive of everything that has ever crashed into the South Pole-Aitken Basin. Every impact over billions of years added a new layer to the mix. And because the Moon has no atmosphere, no rain, no wind, and no moving tectonic plates to recycle or destroy what lands on it, every single one of those layers was still there, waiting. Researchers found fragments of asteroid material buried in the lunar soil, specifically carbon-rich material from the outer solar system called carbonaceous chondrites. These are some of the most ancient and fragile objects in existence, the same type as the asteroids Ryugu and Bennu, and they almost never survived the fall through Earth's atmosphere intact. Carbonaceous chondrites of this kind are also known to carry pre-solar grains, microscopic specks that formed around dying stars before our Sun ever ignited, which makes them some of the most primitive material we can study. These fragments matter for a reason that goes far beyond their age. Carbonaceous chondrites are the same type of objects scientists believe delivered water and organic molecules to the early Earth, the building blocks. The raw ingredients that may have started the chain of chemistry that eventually led to life on this planet. Studying them in their original unaltered state, preserved in lunar soil rather than changed beyond recognition by billions of years of Earth's geology, gives researchers a window into that chemistry that simply did not exist before. The Moon was not just sitting there while life began on Earth, it was collecting evidence. And buried right alongside that ancient asteroid material was an answer to a question that had puzzled scientists for years, one that nobody had been able to answer because the right mineral had never been found in any lunar sample before, until now. This is something most people do not know about the Moon. It has magnetic anomalies, scattered regions on the surface where the rock is strongly magnetized, holding a record of a magnetic field that existed billions of years ago, and then vanished. Scientists have known about these anomalies from orbit for years. What they could never figure out was the specific mineral carrying that magnetic memory inside the rock. Without that mineral, the whole history of the Moon's magnetic field stayed blurry. How was the magnetism stored? Why does it cling to certain regions of the far side and not others? Chang'e 6 gave them the key. A research team identified a mineral called tetrataenite in the far side soil samples, the first time it has ever been confirmed in lunar material. Tetrataenite is a magnetic iron-nickel mineral that forms only under very specific conditions, in this case forged by the intense heat of ancient impacts. Once it forms, it locks the magnetic environment around it into its crystal structure and holds it for billions of years. It is essentially a tiny ancient recorder that never stops playing back the moment it was made. Finding it explained for the first time exactly what carries the strange magnetic signal, scattered it across the far side. But the bigger question, did the Moon ever actually have a real functioning magnetic field, was answered by a different study altogether. Researchers measuring the magnetism locked inside the basalt fragments traced the full life of that ancient field, and what they found surprised everyone. The Moon's magnetic field did not simply fade away smoothly over time. It weakened, then came roaring back with a surge around 2.8 billion years ago, then collapsed for good. The field had a second life, an unexpected rebound that no previous model had predicted. This changes things for the future. Magnetic fields affect how radiation behaves on the surface and how dangerous certain locations are for human operations. Knowing where the Moon's ancient field left its strongest marks tells future mission planners exactly where to look and where to be careful. China found the mineral that records the Moon's magnetic memory and traced the rise, fall and rebound of a field nobody knew had a second act. In doing so, it handed future explorers a map they did not have before. So, why are China and the United States both spending billions of dollars to go back to the Moon right now? Is this about science? Well, not really. But the fuller answer is more strategic and more consequential than most people realize. The Moon has something that makes it extraordinarily valuable beyond its scientific secrets. It has helium-3. Helium-3 is a rare isotope that barely exists on Earth. The reason is simple. Earth's magnetic field deflects the solar wind, which is the stream of particles the Sun constantly blasts outward. Helium-3 rides that solar wind. Because Earth deflects it, almost none reaches our surface. The Moon has no such protection. For billions of years, the solar wind has been bombarding the lunar surface directly and embedding helium-3 into the top layer of lunar soil. Scientists estimate the Moon holds around 1 million tons of helium-3. On Earth, the total accessible supply is measured in kilograms. Why does that matter? Because helium-3 is considered one of the most promising fuels for nuclear fusion, the process of fusing atoms together to release enormous amounts of clean energy with almost no radioactive waste. A single space shuttle cargo bay filled with helium-3 could theoretically power the entire United States for a year. The energy value of the helium-3 sitting in lunar soil has been estimated in the hundreds of trillions of dollars. Now here is the honest part. None of this works yet. Helium-3 fusion has never been achieved at scale. The concentrations in lunar soil are measured in parts per billion, and some scientists think mining it may never be economical. The entire prize is theoretical. But that has not stopped anyone from racing toward it, because if it ever does work, the payoff rewrites the global energy map. And whoever controls the territory, builds the infrastructure, and develops the extraction technology first controls access to it. Beyond helium-3, the lunar South Pole, which is where both China and the United States are specifically targeting their next missions, contains water ice in permanently shadowed craters. Water can be split into hydrogen and oxygen. Hydrogen is rocket fuel. Oxygen is breathable air. A water source on the Moon means future missions do not need to carry everything from Earth. It means the Moon becomes a refueling station, a base and a launching point for deeper missions into the solar system. This is not about a second home for humanity, at least not yet. It is about leverage. The nation that establishes a permanent functioning presence on the Moon first sets the rules for everything that follows. The mining rights, the landing zones, the resource extraction frameworks, and the infrastructure that future missions, commercial or governmental, will depend on. China is not slowing down. Chang'e 7 is heading to the lunar South Pole with a small flying probe designed to search for water ice in craters that have never seen sunlight. Chang'e 8 will follow to test whether the Moon's own resources can be used to build and sustain a human presence without constant resupply from Earth. Meanwhile, the United States, through NASA's Artemis program, is targeting the same South Pole for crewed landings. The European Space Agency is involved. India's Chandrayaan program is advancing. The Moon is not a finished chapter being revisited. It is an active competition between multiple programs, all pushing toward the same question. Who gets there first, who stays, and who controls what comes next? But China went to the side nobody else had touched, and that side was holding the answers to questions the entire field had been asking for 50 years. If this shifted how you think about the Moon, even slightly, it did exactly what it was supposed to do. The Moon is not a dead rock. It is a 4.5 billion year archive sitting overhead every night, holding answers to questions we are only now learning how to ask. And the archive is just getting opened. If you want to stay ahead of what is being found up there, subscribe and stay close. Every video on this channel is built around the same question. What did we get wrong about space? And what does the truth actually look like?